Hi everyone. In 5.1, we're going to use trig substitutions for algebraic expressions and then simplify the result. So in calculus, you may be asked to integrate something like this, an algebraic expression in x. And you actually want to introduce trig. In this case, we want to use a trig substitution, x equals 4 sine of theta. Here I'm being nice. I'm telling you the trig substitution we want to use. In your calculus class, you may have to remember what to do and figure out what the substitution has to be. So what we're going to do now is we're going to substitute 4 sine of theta in for x here, and then simplify. We're going to assume for now theta is acute. All right, we start with the square root of 16 minus x squared. We substitute x with 4 times sine of theta. When you square a product, you square each factor. The square of 4 sine of theta is 16 sine squared of theta. And then, what can we do to that radicand? What can we do here? We can factor out a 16 inside the radicand. And we get what? We get the square root of 16 times the quantity 1 minus sine squared of theta. And how can we simplify 1 minus sine squared of theta? That's cosine squared of theta, says Mr. Pythagoras. And by the way, the 16 pops out as a 4. The square root of 16 is 4. 1 minus sine squared of theta is cosine squared of theta. The square root of 16 is 4. The square root of a product is the product of roots. These are non-negative. So we have 4 times the square root of cosine squared of theta. Now, technically, what's the square root of x squared in general? In general, it's not just x, it's the absolute value of x. So technically, we should start by saying that this becomes 4 times the absolute value of cosine of theta. But now wait, we're assuming theta is acute. And if theta is acute, that means that cosine of theta has to be positive. The absolute value of a quantity that's known to be positive is just itself. So this does simplify to 4 cosine of theta. Again, the square root of 16 minus x squared, after you perform the substitution, ends up being 4 cosine of theta. Now I want to show you something else. So here's our trig sub, x equals 4 sine of theta. So how can we express theta itself? Well, if x equals 4 sine of theta, we can then say that if we divide both sides by 4, we can say that x, I'll do this in a different color. I'll do this in blue. If x equals 4 sine of theta, we can then say that x over 4 equals sine of theta. And then if theta is acute, we can go ahead and say that theta is going to be the inverse sine of x over 4. And as you do this calculus problem, you may end up having to work with, I don't know, maybe the cosine of this or the tangent of this at some point. Well, guess what? Remember, over here, we dealt with those kinds of expressions. Remember this guy here? Cotangent of inverse cosine of x over 3. That's when you get these kinds of expressions, when you get like the cosine or tangent of something like this, and then you can simplify this algebraically using the technique we discussed earlier in 4.7. And you get an algebraic result. Because remember, we started with an algebraic expression. So it all ties together. You're going to do all this stuff in Calc 2. The technique of integration by trig substitutions. Next up, we're going to verify trig identities in 5.2.